Good afternoon. I'm Lauren Rosenberg, a program curator at Smithsonian Associates, and I'm thrilled that you're joining us for today's program, Architects Respond to Nature, Beyond Sustainability, Living Architecture in the 21st Century, presented in collaboration with the National Trust for Historic Preservation's Edith Farnsworth House. To our members, a sincere thank you. Now more than ever, it's your support that keeps us going. As many of you know, Smithsonian Associates is not federally funded and relies entirely on donations and membership support to bridge the gap between program expenses and ticket revenue. To anyone who might be new to Smithsonian Associates, welcome, and I invite you to explore the wide range of programs that we offer, and to consider becoming a member to support our work in bringing you hundreds of trusted learning experiences every year. You can find out about these events and more on our website, smithsonianassociates.org, as well as on our social media channels. This program is part of our World Art History Certificate program, and if you're interested in learning more, there's a link in the chat. Before turning to our guests, I want to quickly point out a few key features to enhance your Zoom experience. Look for the chat box on your toolbar. This is where we'll post relevant information and links throughout the program. Also on the toolbar is the Q&A box, and this is where we'll draw questions from during the Q&A session that follows the lecture. We encourage you to submit your questions throughout the presentation, and we'll get to as many as we can. You may also have noticed that this program includes closed captioning, which you can choose to turn on by clicking Closed Caption on the toolbar. If you're using a tablet or smartphone, you may need to switch the captions in your Zoom settings. Following the program, please take a minute to complete the anonymous exit survey. We value and appreciate your feedback. As I mentioned earlier, today's program is a collaboration with the National Trust for Historic Preservation's Edith Farnsworth House. So now please join me in welcoming Ariana Karakis, Senior Assistant for Exhibitions and Programming at the Edith Farnsworth Historic Site in Plano, Illinois, to tell us more about our partner organization and our speaker for today.
Thanks so much, Lauren. Good afternoon, everyone. Designed by Mies van Dro for Dr. Edith Farnsworth, the Edith Farnsworth House was completed in 1951. It became famous as an icon of the international style and showcases many of the hallmarks of Mies's architectural designs. After being owned by Dr. Farnsworth and Lord Peter Palumbo, the house is now owned and operated by the National Trust for Historic Preservation and hosts 10,000 visitors a year. We're thrilled to be partnering with Smithsonian Associates for this talk. Next slide, please. Our curatorial focus for the next 2 years is nature and culture. The Edith Farnsworth House has become known internationally for its modern architecture, but little attention has been given to the land surrounding it, which has a rich and engaging history beginning centuries before the house was conceived. When Edith Farnsworth acquired the site in 1945, she was aware of its recent past as the Chicago Tribune Experimental Farms, owned by Colonel Robert R. McCormick. But it wasn't until the 1960s that she investigated the indigenous history of the site. The home's second owner, Lord Palumbo, was also keenly interested in the Native American and pioneer settlement histories of the site, the terms he used during the 1970s and 90s, which added to the lore surrounding his use and development of the property as a rural retreat and artistic haven. As part of the National Trust's contemporary focus to tell the full American story, several surveys and archaeological reports began to reveal the multicultural history of tribal occupation from prehistory through the early 19th century, a first wave of Mexican seasonal laborers dating back to World War I, and a steady increase of African American residents since the time of Spanish and French occupation in the 1500s to 1700s. Like the house itself, the Farnsworth site continues to inspire, educate, and engage as a site for history, the arts, and nature. This curatorial focus will highlight not only nature's historic presence to the property, but how the influence is interpreted via contemporary artists like our 2024 Artists in Residence, Asaf Avron. As we celebrate our 20th anniversary of the opening of the Farnsworth House to the public, nature and culture will include tours, exhibitions, programs, and events representing diverse cultural perspectives and generating new information about the land. Tours will resume April 11th as we are finalizing some renovations on the house, and please check our website for the most up-to-date information on our programs and dates. Now I'd love to introduce today's speaker for the talk. Next slide, please. Lindsay Baker. Lindsay Baker is a movement leader, speaker, author, and podcast host working nationally and internationally to transform the building industry for a regenerative future. As CEO of the International Living Future Institute, Lindsay advocates for a world where everyone lives in buildings that are safe, healthy, decarbonized, and affordable. A lifelong environmentalist and building scientist, Lindsay has spent her career leading and scaling impactful initiatives, partnerships, and programs across sectors. She was a senior fellow at RMI, taught at UC Berkeley, and serves as a board member and advisor to numerous nonprofits and climate tech startups, including the Clear Fight and Spur. Prior to joining the Institute, she served as global head of sustainability and impact at WeWork, co-founded successful smart building startup Comfy, and worked with Google's real estate sustainability team, and was a building science researcher at UC Berkeley Center for the Built Environment. Her career began as the U.S. Green Building Council, developing early standards for the LEED rating systems. Lindsay is a published author and frequent speaker on subjects including climate action, the regenerative building movement, and special impact in the building industry. She holds a bachelor's degree in environmental studies from Oberlin College and a master's degree in architecture and building science from UC Berkeley. She grew up in Atlanta, Georgia, and now lives in Oakland, California, where with her partner and their many precious houseplants. Please welcome me in welcoming Lindsay.
Thanks, Ariana, for the lovely introduction, and it's nice to be with you all today. I'm glad I have a couple of the houseplants aforementioned in my bio here to keep me company. But it's great to be here. Thank you all so much for having me. It's a delight to be in company with people who care so much about buildings and the legacies that they create. So I'm excited to hopefully tell some inspiring stories for you all today, but also just give you a sense of where the movement is in our society, I guess internationally, but also specifically here in the US around how architects and how the building industry are approaching issues of climate. So I'm going to share my screen here and hope this goes well. Putting it into slideshow. I hope that works out. Someone let me know if you can't see my slides. So as Ariana mentioned, I am the CEO of the International Living Future Institute, and I guess the link is now in the chat if folks want to know a little bit more about our nonprofit. But what I'll also say is I'm a child of the green building movement that has come up in the past, now almost 30 years, which I'll share a little bit about in a second. And also just someone who thinks very deeply about why we build the way we build and what it looks like for us to shift those practices in a way that fits within the constraints of our planet and within our own health and the health of our communities. So today we're going to be talking a little bit about some of what got us here today, or what got us into the situation that we're in as it relates to buildings and climate, and then what we're doing about it. So we're starting off here on the roof of a building that I know and love very dearly, and I'll talk a little bit more about later, the Bullitt Center in Seattle, Washington. But it is a building in a large family of buildings that are growing around the world today and over the past 20 years that I'm excited to share more about with you all. These are buildings that have shown that it's truly possible to build in a way that has a positive impact on the world. That these are buildings that essentially produce more energy than they consume. They clean all of their own water. They're completely non-toxic. They do good in their communities. And they're showing us that it is within the realm of our imagination and also within the realm of our potential to build and to live within the constraints of our planet. And this has been a couple decades in the works to get all of these buildings out there into the world. But now that we have them, we're very busy as an institute and as a larger movement to make sure people know that it is possible and indeed delightful and necessary to build within these constraints. So I'll tell you more stories about some of these buildings in kind of the latter half of the talk so that you get a better sense of how people achieve what they've achieved in these building designs. But I wanted to start with some pictures, first of all, because of course it's a Sunday and we all need a nice set of lovely photos to get us going and to get us inspired about this work, but also to dispel any sort of myths that you might have around what it looks like to build within the constraints of our world. Doesn't look just one particular way, and it doesn't have to be ugly. It doesn't have to be void of sort of beautiful design and critical design work, and in the thread of what it meant for someone like Mies van der Rohe to design in within a philosophical frame that was quite profound. I think many of the buildings that we are seeing now come out in the world have similarly rich ideological frames and stories to tell. And yeah, I'm excited to share a little more about that. But just the context to start, it's what roots us in our work and what roots me in my work is that everywhere in our world today, and I think many of us feel this very viscerally, we know that our planet is in danger and that we as a species are in danger as we address the challenges of climate change, and not just climate change, but biodiversity loss, rising sea levels, all of the things that come along with that, pollution, the way that our cities have grown in very oftentimes unsustainable and also very inequitable ways. So these threats are very visceral for us, and I think for many of us are feeling almost insurmountable. We are affected by it along with every other species on this planet. And that experience of going through that, I know, has been profound for me, but also profound for all of us. And it's important that we all understand, I know many of you don't work in the building industry, but many of you probably do, that the built environment has a really significant responsibility here for the world we've created and the impacts that we are having on our planet and on our bodies and on our communities. So buildings and construction account for 37% of all energy-related carbon dioxide emissions. About half of that is from what I'll share a little bit later, the difference between embodied and operational carbon, but basically half of it is the energy that goes into electricity and heating and such in buildings, and the other half is related to what we call embodied carbon, the carbon that makes up that is used to make the materials for our built environment, so concrete and steel and glass and all of these things. We're also responsible for 32% of all natural resource usage on the planet and 30% of all waste production. Not only that, but here in the US, buildings are where we spend all of our time. So when we think about the impacts that our world has on our health, a lot of it is what we expose ourselves to through our buildings. So they are responsible for a lot of higher asthma rates in many communities and in many building types. They're responsible for our mental health in very deep ways. They can be responsible for all sorts of carcinogenic exposures that we'll talk about briefly here today. So the building industry has a lot on its plate to work on and to improve upon that we've come to understand over the years is a really significant set of responsibilities and impacts we have out there. Hopefully this graph is somewhat familiar to you, at least in some ways. This is showing the levels of, this is showing the actual temperature change that we have seen on our planet just in the past, now, I guess 80 years is showing. And it's a stark reminder of what we have ahead of us. I think one of the things that we'll talk about a little bit today is that architecture as a profession is always changing, right? And so are many industries and many professions and many bodies of work and sort of discourses, intellectual discourses. And the challenge for us in the architecture world now is that we can't change at the natural rate of change that an industry or a profession might change. We have to change in line with a much more urgent deadline, which is essentially, it's not even really a deadline. It's just that we are running ourselves off a cliff when it comes to the temperatures of our planet and the impacts that those rising temperatures are having on ecosystems, on our weather, which then impacts our built environment heavily, etc. So we are trying to do a very hard thing right now, which is to change an industry, change a profession as fast as we possibly can to get us to what we refer to as a 1.5 degree temperature change, where we want to be trying to flatten out that temperature change collectively with all the other industries around the world, such that we can sustain some semblance of familiar life on this planet. But doing that is an interesting challenge. So I mentioned this, oh, well, I guess this is telling a slightly different version of the story. More than half of the building operations. Actually, I think this graph might be a little out of date. We've been learning more and more about building material and construction and the impacts that they have on the total CO2 numbers, total carbon dioxide numbers. And I think this is actually a little bit underestimating building materials and construction. But nonetheless, I guess the point here to emphasize is that we are a big chunk of CO2 emissions in the world. And that just in case you're curious, oh, well, like what else is in there? What is not included in the building industry? That's transportation, so cars and trucks and things. And then industry, which is all of the ways that we build, so we make things. So, you know, from manufacturing, etc. And another. So another key statistic that I think is important to share, especially for those of us that are interested in historic preservation, old buildings, modern architecture, etc., is that in 2040, 2/3 of the global building stock will be buildings that exist today. And without upgrades, they will still be emitting large amounts of greenhouse gases. And this is even more so. This is probably closer to 3/4 now. So what this is meant to just emphasize is that we will not be able to design our way out of the problem of buildings and their impact on climate change. We will have to go through significant renovations like the Farnsworth House is doing right now, which is wonderful. And so those upgrades and how we actually make those happen are a big piece of the overall global movement work that we're trying to do to address this challenge. I'm not going to speak about it quite as much today because we're going to talk more about architects and yeah, that side, but it is a stark reality. At the same time, we are building a lot. All over the world, global building floor area is expected to double by 2060. So this is less so in developed countries. So the larger the central blue dot, the more buildings are already there, and the largest blue dot, the faintest one, is the expected demand. So you can see that a lot of construction is going to be happening in India, certainly in Africa, and many other parts of the world. But some of us are going to be working more on our challenges of renovation, and others are going to be working on how to build well in the first place. And then I added this slide in just for this community, just to make sure, as we sort of think about maybe where green building as a concept sits within a longer time frame of people thinking about and theorizing around buildings and the role they play in our lives, I thought I would just situate a lot of what I'm going to be talking about today within the broader context of sort of modern architecture and things, to say that before 1973, there was a great deal of attention and thought put towards things like how to use the heat of the sun to our advantage to heat and cool buildings, how to daylight buildings. Obviously, before the invention of electric light, that was a major facet of what architects spent their time doing and practicing. Site-based design that was sensitive to and thoughtful around its relationship to nature. These were all trends before 1970. And, Mies van der Rohe, many other architects, Richard Neutra, Philip Johnson, a number of them, they all had sort of, and really Frank Lloyd Wright, like all of these architects had pretty deep relationships with the idea of the natural environment and Frank Lloyd Wright used the term organic. These were terms that they were very comfortable with and interested in. Oftentimes in modern architecture, the desire was to reconnect people or to ensure a connection between people and the natural environments around them. So those big, beautiful glass windows that you see in many classic modern architecture buildings were moves they were making to make sure that we felt that we were a part of something bigger than ourselves, that we were a part of the ecosystems around us. That in many ways, at least, was the origin for many of those early thinkers. But that type of thinking was quite different from what happened that has propelled the significant advancement of green building, what we now call green building practices in our world, especially here today in the US. That really started with the oil embargo of 1973, when we started understanding scarcity. And we started understanding that we only had so much energy we could consume. There were some, in the 80s was when we first started to understand that global warming was a thing, at least more broadly speaking, when that started to catch attention. And then in the mid-90s, we had the first climate change conference at the UN scale. The Paris Agreement happened. Unfortunately, 20 years later, after they started meeting about the issue. But so these were some of the key inflection points that precipitated the creation of what we now think of as sort of modern green building, which has been punctuated by a number of things. First, starting with energy codes. So the fact that a lot of buildings now are required to have a minimum amount of, good energy performance. That started pretty much right after the oil embargo of 1973. But then you move into the 80s and 90s, people start kind of forming nonprofits and communities around these ideas, typically focused on energy and carbon. They wouldn't have really called it carbon at that time. It was mostly energy. And then by the early to mid to late 90s, you start to see the creation of systems like LEED. So BREEAM is another one that started in the UK in the early 90s. Passive House is another one that came up around the same time as LEED. These were all essentially frameworks along with nonprofit organizations that promote the practice of a suite of what we now think of as multi-attributes. So not just carbon, but health and water and landscape and biodiversity and all of these kinds of impacts, the attributes of a building that make them have impacts on the rest of the world around them. These systems started coming up to help to sort of frame that and to transform the market towards better ways of building. So the Living Building Challenge is what I'll be sharing a little bit more about today. That's the program that we run here at the Institute. And that came a little bit later and has a slightly different philosophical angle that I'll share that I hope will be inspiring and interesting for you, as well as sort of the WELL standard, if you've heard of that. So these are all this different, it's many complain at this point in the building industry that there are far too many stamps that a building can get or too many acronyms that we try to keep track of. the various types of recognitions, basically, that a building can get for higher performance around climate, health, social impact issues. But it is sort of the way we've learned to evolve our industry is through these types of designations, along with just the building of community around them. So, conferences and professional designations and all of these things. So it's been, I think in many ways, a very successful movement. As modern movements go, we've managed to really impact the way that people build all over the world through the creation of these kinds of programs. But we are nowhere near where we need to be. So that leads me a little bit to what we do here with the Institute. We ask ourselves every day this question, instead of a world that is merely a less bad version of the one we currently have, we want to know what good looks like. And so I guess maybe just coming from that history point, when LEED and these other kinds of programs were coming out, and as was mentioned, I worked on LEED in the very early days of its life. The idea was to give people, architects, engineers, construction folks, etc., a sense of what it would look like to do better, to improve, to take a step in the right direction. And these were frankly times when I think when those programs were created, when the sense of urgency was not quite as great. So perhaps some LEED buildings that don't feel particularly super green or healthy or high performing, and or you've heard some critique in the media about it. Perhaps you have not, but our world is full of sort of asking ourselves the question: have we aimed too low sometimes, I guess. And LEED has continued to evolve to have a higher and higher bar, but nonetheless, it's we have to ask ourselves: have we transformed the market, or have we made systems that recognize like a little bit too much of the standard operating procedure? And so for us at the International Living Future Institute, the question, what does good look like, is a very profoundly different question. It's not asking how does a building maybe make a few steps in the right direction. It's asking, what does a building look like when it is truly giving back positive impacts to the world in a variety of impact areas. And so that sort of question has taken us a long way. We have learned to use this metaphor of the flower and asking ourselves what good looks like. In many ways, I think we look to nature for inspiration every day, and have learned what a wonderful teacher and foundation it can be. But we use it as a blueprint for what we think of as regenerative design. And when I use the word regenerative, I'll just say we use that term mostly to describe something that is not just sustainable. So sustainable kind of implies that it is neither good nor bad. It's just kind of flat. It's made up for the impacts that it's had on the world in some way. So there are better definitions. Obviously, that's not the one that people use as sort of the classic definition of sustainability. But sustainability as a term tends to sort of be that definition, is just, let's make sure that we are not bad. And regenerative implies, and hopefully you're starting to see this term show up in things like food or even clothing out in the world. And we are in a large community of people working on regenerative systems. But the idea is that we design these systems that in their design and in their operations, they give back. They help to heal our planet. They help to heal us. So in that context, the Living Building Challenge is one of those types of programs that seeks to regenerate our planet. And it is sort of the center of the work that we do at the Institute. Okay, sorry, I'm just going to make sure I pay attention to these Q&A things. Thanks. All right. So a couple of central points about the Living Building Challenge. The Living Building Challenge projects, all of the buildings that pursue this challenge have to be holistic. They have to address all what we call the petals of the Living Building Challenge. And also every building has to be based on actual performance of the building. So this means that you can't just build a building and get it designated as a living building. It has to show in operation for an entire year, oftentimes more, that the building is operating the way it's intended to. So that is significantly harder and conceptually more important to us than what some may use to sort of define what a good building looks like. So across these are the 7 different petals of the Living Building Challenge. And I'll just share a little bit with you in some stories of specific buildings, what this can feel like. But the place petal is all about the relationship that a building has to its ecosystem around it and to the specific physical land that it's on. Water is around the water systems of the building. Energy, same energy, electricity, heating, cooling, etc. Health and happiness relates to how the buildings create healthy environments for the people that live and work in them and learn in them. Materials goes to where the materials come from, their provenance and their chemical content. So we're looking essentially to make sure that the materials that go into living buildings are safe for our people, which is unfortunately a really challenging thing to do in our world today. Equity relates to the community impacts of a building, how it relates to the workers that work to create the building, how it relates to the community around it, and the role that it plays in giving back to the community in particular. And then beauty, which is generally speaking about the ways in which nature is introduced into the buildings in a way that provides an element of biophilia for us and brings beauty into our lives. So I did mention this sort of difference between sustainable and regenerative. Just in case this is helpful, we kind of usually draw this out. This is more perhaps relevant for professionals in the building industry, but people tend to think about green as a slightly less bad definition. And when we're talking about living buildings, it's really about what it looks like to be positive. And then perhaps a nice tie-in back to some of the modernist architects. We love this quote from Buckminster Fuller, to make the world work for 100% of humanity in the shortest possible time through spontaneous cooperation without ecological offense or the disadvantage of anyone. Classic Buckminster Fuller moment of phrasing something quite simply and in an efficient way, but of course, easier said than done. So just so you all understand about the Institute, and this isn't really meant to be too much about us, but we run these different programs across the sort of the building industry more broadly to inspire change in different scales. And so I'm mostly going to share the building scale with you, but we also run programs, the Living Product Challenge, which is to really promote change in the product world to improve the performance of and impact of building materials, various building materials and building products. And the Living Community Challenge, which is a program that we don't actually certify for, but is a program for communities to try to pursue high levels of ambition around regenerative practices at the community scale. But then these other 2 little ones I just wanted to mention quickly, zero energy and zero carbon, in case there are folks who are really specifically interested around climate change. Because as I mentioned, all of our other programs are quite holistic. Our energy and carbon ones focus specifically on the carbon impacts of the built environment. So I thought it might at least be worthwhile for you all to understand the little bit of nerdiness around these 2 facets of carbon impact that we work on in the built environment. In part because I guess I find it fascinating that they can sometimes disagree with each other, but also because I think it's important to just to know what we mean when we talk about climate change in buildings. So operational carbon is basically the carbon that's emitted when a power plant has burned some sort of a little fossil fuel, and in order to produce some electrons that go into a building that allow that building to power its computers, or light a space with electric light, or heat or cool. That's all operational carbon. And then embodied is when a manufacturing facility burns a little bit of fossil fuel to power a furnace that is making an I-beam for a structure of a building. So same carbon emissions, but they're going to very different facets of building. Operational lasts over time for the entire life of a building, and the embodied happens upfront as it's constructed. So we work on both, but we do have specific programs that really just tackle, and there's a whole kind of community of folks who just work around carbon emissions, in part because of the urgency of this issue, but the sort of the technical complexity of it. And these are some of the buildings that we personally have certified around carbon only. So for example, the Climate Pledge Arena in Seattle, Washington, but also now more recently, this logistics center in Eindhoven in the Netherlands. These are examples of buildings that are unfortunately not handling every aspect of the impacts they have on the world. They're just focused on carbon, but they are managing to significantly reduce the embodied carbon that goes into the construction of their buildings, oftentimes through things like the use of mass timber as a structural element rather than using concrete, which is quite bad from a carbon perspective. And then also having 100% operational carbon covered by the generation on site. So you can't see in all these buildings, but they have huge solar arrays usually to ensure that they can do that. So a lot of the work that we continue to do in community with many other nonprofits and corporate leaders and others, academics, is to address how these things get done, and the standards, the guidelines, the benchmarks, the sort of how-tos are all a big part of that. But I'm going to not spend too much more time on these on the carbon specifically. I just wanted to kind of give you all a little bit of a deep dive into what the carbon side of our work looks like. So last set of pretty pictures of these zero carbon buildings. And yeah, if folks have questions about how this works, I'm happy to answer them in the Q&A. But I'm now going to just turn to some stories. Actually, I'll just check the questions really easily. Oh, why is concrete bad for buildings? Okay, I might wait for some of these because I think there's nothing too specific clarification, but bigger questions. But thank you for those. Keep the questions coming. And so I want to share a story of 3 buildings with you that we've worked on over the past now 10 years, I guess actually more, probably close to 15, but the oldest one opened 10 years ago, to show just how we rethink the process of designing and constructing and then operating buildings today in a way that creates space for the future we need. So this is starting with the Bullitt Center. So I mentioned this one. This was the one you saw in the first slide, the roof of this building. This was one of the very first living buildings that was ever certified. And it just celebrated its 10-year anniversary of being open. So this is an office building. It is in downtown Seattle, and it houses a number of different types of businesses. It actually used to be our headquarters until we went fully remote a few years ago. And one of this is a picture of people coming and going on what's called the irresistible stair. So actually, let me see if I can show. So you can kind of see the main entrance to the building in the shade here across the street from these trees. Next to that main entrance is this irresistible stairway. It's a naturally lit, beautiful wood constructed stairway that basically the reason that we do these kinds of irresistible stairs is to get people to use the stairs. It's a little bit of energy savings from not using the elevator, but it's also good for our bodies to have access to stairs. So I still love how happy these people look as they're walking up and down the stairs. The building has external shading that's automated. So these things that look kind of just like a classic Venetian blind are on the outside of the building, and they are programmed to shade the building automatically when it's hot and or there's direct sun coming in that might create visual discomfort for the folks inside. And then to open up when they can to provide natural light so that you don't need to use electric lighting. So these kinds of technologies are employed in many buildings around the world at this point, but this building was sort of one of the first to try this type of thing. A couple of numbers for you, or just sort of number slides. So this is depicting the roof size of the building. So this shows that basically if this building were designed in a way that was a little bit more of a classic typical building, then the energy use of the building would have required a solar array that would be that large, the top one, compared to the actual size of the building. So a ridiculously large solar array that would not have been buildable because it would have gone over the tops of the neighboring buildings and would have been a structural challenge and just, yeah, not an option. So that's what a typical building of that size would use in energy consumption, essentially, if that. So a building of this same size that was meeting the energy code of that time. So in other words, most new buildings would have still required a solar array that would be the second size down. So still quite a high amount of energy consumption, and the solar array would be too big. A LEED Platinum certified building, so the buildings with the highest LEED designation, if you're familiar with LEED, would have required then the third size down. So still much smaller, then much better, much less energy consumption, but still quite a large solar array. And then you see the depiction of the actual bullet center below with the solar array, the size that it actually ended up, which is just this nice sort of overhang around the exterior of the building. So in other words, the way that they were able to ensure that the building could run entirely on the solar that was on its roof was by using as little energy as possible. And that is how it became feasible to do. So where did that happen? So energy use intensity, EUI, is this number that we use in the building industry to describe how much energy per square foot does something take. And so you can see here that we were able to, the project team, I was not involved in this project before my time, was able to reduce significantly the major aspects of a typical building's energy consumption. Space heating is a huge one. And this would have just been a typical building in Seattle. So you're not seeing a lot of cooling because it's a relatively cool climate. Plug loads is all the things we plug in, all of our electronics, et cetera. Cooking, lights, et cetera. So these are all the things that typically a building uses, and the Billet Center was able to tighten it up to significantly lower consumption of energy across the board. So that's the story of the Bullitt Center. I'm going to move on to the second one in our series. So the Candida building has now been open for about 5 years, and it's in my hometown of Atlanta, Georgia. The Candida building's on a college campus, on Georgia Tech's campus in downtown Atlanta. One of the things that happened when the Bullitt Center was constructed, and some of the other buildings were constructed in the early days of the Living Building Challenge, is that people said, oh, well, that's all well and good that you could build a building like that in kind of a more mild climate, but how are you going to do this in a climate that's hot and humid and requires a lot of typically air conditioning to keep people comfortable? So that was part of the big challenge that the team at Georgia Tech took on when they embarked on this building, which is a lovely building. It's very easy to walk around if you happen to be in Atlanta. It's downtown and on the campus there, so you can kind of go and get a sense of it. So just to share a little bit of the aspects of the design for this project, many of these are blueberry bushes. They also have honey that they grow on the roof of the building here. They obviously there's a classroom element to a lot of the work that happens at the Candida building. So they're teaching students in a variety of ways for a variety of different classes through the ways that the building has been designed and used. One of my favorite stories about living buildings is this one. This is a program that the Candida team took on to salvage wood that had been from demolished projects on Georgia Tech's campus in the previous years prior to the Candida building being constructed. Specifically through a program that helped formerly incarcerated folks with job training, essentially, to get them into higher paying jobs, steady jobs that are really great long-term jobs in the construction and building industry. So this is the factory that was taking those demolished wood components from Georgia Tech's campus and then turning them into the flooring and other sort of architectural details inside the Candida building, while also creating jobs and economic mobility for the community in Atlanta. Water, there's obviously a lot of beautiful water work that happens here to make sure that all of for example, the stormwater runoff in the building does not leave the site, but is absorbed back into the soil. Energy consumption, it does, as I had noted, it regenerates more electricity than it consumes. And I should say all living buildings, there's no on-site use of natural gas of any kind. So there's no fossil fuels being burned in living buildings. They are all electric. It's a beautiful space. It's I love some of these ways that you can kind of open up the indoor-outdoor. The shade structure that is created by the solar panels is also a really lovely way for people to feel like there's a bit of a porch, which in the South we particularly love our porches. And then here's a last shot just of the interior of the building, so you can see that wood that was reclaimed along the ramp and in the flooring here. So the Candida building learned a lot of lessons from the Bullitt Center, because every evolution of these buildings, there's lessons that we learn about how to make the buildings more affordable, easier to build, find better materials, find better systems. And then the last building I'm going to share with you is the newest of the bunch. This is a building in downtown Portland, Oregon, and it's I think it's actually just still finalizing its certification, but this is the headquarters of an engineering firm called PAE, which actually worked on both of the previous buildings and then had the good fortune to be able to construct their own headquarters as a living building in a downtown area. So you can see a couple of things that I think are important for us to all understand here. about where green buildings are today, which is that it doesn't look like they used to. It doesn't look like it has that sort of classic, sloped south-facing roof necessarily. It's not, surrounded by there's no green wall. It's not. It may not have some of the bells and whistles that we think of as being green building. But in fact, this building, by all definitions, is giving back more to our planet and to our health than what it took away. So this is Paul. Paul's the president of PAE Engineering, and this is a trip I took up to visit the building just a couple of years ago, with Paul sharing with excitement how they fit all of this solar onto their roof to try to pack it on as efficiently as they could. They actually did have to buy and install some solar off of their roof. And so what they actually ended up doing was purchasing some solar panels that were put onto an affordable housing community nearby. And they essentially share that array with the affordable housing community, but they paid for the solar panels themselves, in essentially just a way of ensuring that they were giving back to the community and being, living the living building challenge. So this is perhaps the least sexy picture you'll see, but also actually two pictures of what real where the magic happens with green buildings these days. So on the left, what you see is the building scale wastewater composters. So all living buildings process all of their own waste on site. And that means that when we flush a toilet, the human waste goes into these and they are composted in the basement, and then they are regularly harvested. People come and remove the compost once it's become compost, and it's taken to local farms to use as compost in their in agriculture. They actually also have a very cool system in this building that takes the pee from the urinals and concentrates it into a sort of a crystal fertilizer that is also used by local farms. I think there's a liquid form of it as well that they've been selling in stores. So kind of a wonderful way of making sure that you harvest the nutrients from your building. And then on the right is a microgrid. And this is just a big piece of equipment in the basement, but what it allows the building to do is to be online when the power grid goes down. And that is increasingly a helpful thing for communities that essentially need places of refuge when we have significant climate events, weather-related climate-related weather events that knock out our power grids. These kinds of systems can enable one building in the community to still have power and water and wastewater treatment, and to essentially be resilient in those moments where communities lose a lot of their critical infrastructure. So these kinds of pictures may not be the prettiest to look at, but they are some of the critical guts of what it looks like to really build great buildings today. But the pretty side of it is still there. So this is mass timber I mentioned. So using, in other words, wood as the structure of the building rather than concrete. And then, back out to the outside, I'll mention the windows themselves. One aspect of beauty that they built into the design is that the windows are actually a golden, golden rectangle. They're sort of they are sized for something that we find pleasing, I guess. That's a simple way of putting it. So these buildings and many more are all around the world, impacting people who visit them every day, people who get to hear their stories, people who live in them and work in them and learn in them. And they are just a handful of examples of what we are capable of. So there are single family homes, there's homes and very, very cold climates, high on the tops of mountains and deserts, all sorts of things. And the question that we're now facing for ourselves is, how do we go from possible, what these buildings have proven, to scalable, to making all buildings built this way? So I have a lot to say about this, but I'm going to come to the end of my time in a minute, and I want to make sure we have time for conversation. So I guess I'll just share a couple of things. One is that we are trying to build a movement. We work every day to expand our community and to raise awareness about these building practices with architects, with engineers, construction companies, real estate companies, et cetera, but also just with normal folks, because we all have a say in what our buildings look like, what they're made out of, what we buy and put in them. And those decisions that get made, I think for a lot of people, can feel really unapproachable, complicated, like you're not really sure what decision to make. So we are trying to make it easier to understand, easier for people to know that we are all collectively in control. And the last aspect of that that's important, that makes movement building particularly important, is that there are a lot of policies at local, state, and federal levels, if you're here in the US, but at different scales of government in other places around the world, that impact how we can build and how we can't build. And those get legislated. So having people in positions of, essentially policymakers, legislators, et cetera, who understand the importance of building good buildings, and how to do that well, how to do that at scale, that can change our world profoundly. So we hope that you will take more time to learn a little bit more about the decisions that we can all be making, but importantly, how things like our local codes, whether we have them or not, impact what we're allowed to build and what standard we're building to. And then that our legislators and other people in our community understand how important it is to do that work, so that we can hit the goals that we have as quickly as we can around climate change, but also for the other impacts that we have on our bodies and on our communities around the country. So I will stop there and at least just share our website for those of you that want to learn more, donate. We are a nonprofit. We have a membership program if you'd like to join as a member. And you can find us at living-future.org. So I will stop sharing my slides, and maybe Lauren has some good questions that have come up in the course of the conversation.
Thanks so much, Lindsay. That was a great presentation. We do have some questions ready for you in the Q&A, but there's still time to add yours if you have one. I'm going to start with just a few questions about some of the buildings that you showed us.
Okay.
Someone wants to know, has the Bullitt Center met the 16 EUI projections in actual use?
Yes, it did. If you actually, so I wish I'd provided this link for you all in the chat, but they just celebrated the 10-year anniversary and did a press release around the energy performance that they've hit for the building. And they did hit those numbers. They actually, it's very adorable. I get graphs every year or so showing how the actual energy use intensity is doing. One thing worth knowing, and I'm sorry if this is too nerdy for most of us, but energy use intensity doesn't take into consideration how many people are actually in the building. And so during the pandemic, of course, the energy use intensity for many buildings went down significantly because no one was using the buildings. And so that was the case for the Bullitt Center, that, there were a few years there where they were quite low. But I will say one of the lessons learned they had from that building was the composting toilet system had to be pulled out. It didn't end up working as well. So the newer versions of them have been improved upon, but I don't want you to think that everything that they tried to do in that building actually worked out, because that's really the case. So I think the energy use intensity has been kept quite low though. Yeah.
Great, thank you. And for the Atlanta building, someone wanted to know, what is the roof constructed of?
Oh, well, I mean, so just to be clear, the solar array itself is not so much the roof as it is like a hat over the roof, right? So what you're seeing in a lot of those pictures is a solar array suspended on top of the roof. I don't know the assembly of the actual roof, but I do know that they used a lot of mass timber in the structure of the building, so I'm sure there is some mass timber in there. But that's a good question. We have case studies, elaborate case studies on all of these buildings on our website. So you can find out more, and you may be able to find out more detail about what's in the roof.
Great, thank you. We do have a bunch of questions about solar panels.
Okay.
I'll start with a few. How
Great.
long does it take a solar panel to pay back the energy that it took to create it? And this person is saying they realize that it likely makes a difference where the solar panel is installed and what the weather conditions are. But do you have kind of a general answer?
Oh, geez. So, so the simple answer is, from an energy consumption point only, it is not that bad. I wish I could tell you, but I think I don't want to mess this up. Solar panels are entirely worth buying from the perspective of their overall, what we call the whole life carbon perspective. They definitely do have a more positive impact from a carbon perspective. I think one of the things that makes that a more complicated question, though, is the mining and labor practices and health of the workers and all other kinds of non-carbon impacts of solar cell construction, fabrication, I should say, is those are other impacts that we care about. So if you're just looking at carbon, yes, they're absolutely worth it. The impacts of them and the sort of scarcity of some of the minerals that actually go into solar cells are becoming a bigger concern around the world. But yeah, I wish I could tell you, but if you were to search something along the lines of like whole life carbon of a solar cell, I think it would give you the right number, and it would be better than the one that I would be guessing at right now. Yeah, I can't say that I'm a complete solar panel expert, especially because they have gotten wildly more productive and cheaper, and sort of the processes have changed a lot over the past 20 years. So there's only so many technical details I can keep up with, but go for it. Let me know what the next one is, and I'll see if I can.
Great. I'm not sure if this question was specifically targeted at some of the images you showed us of solar panels on buildings, but they want to know, are there ever attempts to rotate the solar panels to maximize the electrical output
Oh,
currently
sure.
or on future designs?
Yeah, so you could see that actually in the PAE building, for example, something that's happening there. So typically a solar panel, if it's fixed in place on a roof, it's going to be pointed towards where the sun for that particular place in the world is based, the latitude in particular. What we do is we find where the sun is at noon on the spring equinox, so actually quite close to today, and you point the solar panel that way, because that is sort of the center point of the sun's path over the course of a year for that particular point in the world. So that's how we decide the way the solar panel typically faces. You can have solar panels that move, but typically in buildings, we don't have them move around. They don't have moving parts. They're just fixed on the roof or on the landscape or something. So like you may see sometimes a solar field, like if you drive by some and they're kind of masted and they look like a little bit like an umbrella. Those ones, oftentimes they'll be able to move around to pick up the sun's energy most efficiently. But that mechanism and amount of energy that it actually takes to move it around doesn't always, price out well for most solar installations. But in the PAE building, for example, you'll see that a bunch of the solar panels are not actually, in order to pack as many solar panels as they could on the roof, they actually have some of them, so they're installed kind of like this. So some of them are facing perfect and some of them are not. And they did that so that they could get as many solar panels as they possibly could on the roof, and they were a little less worried about whether they were at optimal angles, because that way they're not shading each other. If you put them this way, then this one shades this one on the bottom. So that was a design that worked for them. So it's not always that the solar panel has to face directly in the, towards the sun and at noon on the equinox, but generally speaking, that's the most efficient place if it's going to stay put. I hope that answers the question in the nerdy way that you were hoping for.
I hope so too. Okay, back to a question that you saw in the chat earlier. Can you tell us why concrete is bad for buildings?
Yeah, sure. So concrete's an interesting thing because in some ways it's really just manufactured stone. So it's made up of lots of little pieces of stone and then sand that gets heated up and minerals that get heated up at a very, very high temperature so that you can then make the stone whatever you want it. So the reason that concrete has such high carbon footprints is basically because of the degree to which you have to heat up the cement. So concrete is actually made up of aggregate and cement. A lot of people think cement and concrete are the same thing, but cement is the glue inside concrete, and that glue is to make it. It's very carbon intensive. It's basically made in factories where you have to heat a furnace very, very hot in order to get that the chemical reaction to happen to produce the cement. And heating up these blast furnaces very, very hot all the time for just the sheer quantity of concrete that we have in the world makes it one of the largest carbon emitters as an industry that we have on our planet. So it's really just high heat, et cetera. So yeah, great opportunity for innovation. There's a lot of people trying to make lower carbon concretes now by changing the chemical composition, figuring out ways to maybe use hydrogen to power the blast furnaces instead of fossil fuels, et cetera. But we're still a long way to go on that one.
Great, thank you. You touched on this a little earlier when you were talking about the EUI going down during the pandemic because the building wasn't being used.
Yeah.
Now that many of us are working at home, how does this change or affect sustainable architecture?
Well, a couple things. One is that there's a big trend now towards office to residential conversions in cities. So you can read some great articles in the New York Times and Washington Post and things about projects to turn office buildings that are basically no longer needed because our society right now anyway has a much lower demand for office buildings, to turn those into residential buildings, which from a climate perspective is a great thing because it means we don't have to build new buildings. We can retrofit existing ones. Hopefully ones that are nice to live in and not a kind of a gross 1960s glass box that doesn't have a lot of, natural light or, operable windows or things like that. So that's a big one, is that we're trying to figure out how to utilize all of those buildings that we had other purposes for, to make them into homes, or other building types, but basically to reuse the buildings. I guess some aspect of this also just shifts responsibility. It means if you're someone that's working from home, or if a lot of us are working from home, it means that the energy use intensity of our homes goes up and the energy use intensity of office buildings goes down. And so that dynamic doesn't really shift the amount of energy that gets consumed. Not in a noticeable way anyway. I guess maybe the last little bit of it that I think is very important is that an office building if there's anyone in it, it tends to use something like 80% of the energy use that it would if it's fully occupied. So very kind of high vacancy office buildings are a huge issue for our overall carbon footprint of our building industry, because if no one's in them, they're still running all of these core central systems. And it's just going to the 3 or 4 people that decide to show up that day, if you have some of, those flexible work policies. And that type of setup, it's very hard. Smart building systems and all these kinds of things are just not advanced enough to be able to say, okay, well, we're only going to use 10% of the, cooling energy today because we think there's only 10% of people in the building than there is usually. It just cools the whole building. There's some little bit of relaxation on that, but it's pretty bad. So that's perhaps the worst impact that we've had of people kind of leaving office buildings, is that they now tend to be a lot more vacant and yet still use the same amount of energy.
So many implications from this shift, and this is just one big one.
Yeah, just one. Yeah.
Someone noted that there is a lot of tree and housing waste from natural disasters or just dead trees falling, and none of these potential building supplies seem to be reused. Is there anything that can be done with materials like this?
Yeah. Well, I'm going to talk about trees for a second. So a couple of things. In particular, wildfires, which is maybe one aspect that that this person is thinking about. There is actually something. There is a particular type of wood, lumber, that comes out of wildfire reclaimed trees, basically after the wildfire has gone through. It's a lower quality of lumber, but there's still a lot of value to it, and it can still be used in construction. So there's a sort of a growing market that we're working on with other people for that type of wood. There's also what we call restoration wood, which is wood that is harvested specifically with the intention of preventing wildfires. So through practices that are more regenerative, forestry oriented, to ensure that the forest is healthy enough that at least when a wildfire comes through, it doesn't completely destroy things. So there's a lot of work happening there. If you're really interested in some of the technical aspects of it, we're a part of a group called the Climate Smart Wood Group, which you can look up. I think it's climatesmartwood.net is our URL, where we work on a lot of those kinds of things. I did mention in the Atlanta building that wood that was reclaimed from old buildings and put into the new building. That kind of practice is quite common with wood, or it's quite feasible, I should say. We still throw out an enormous and offensive amount of lumber that sometimes just goes from the forest to the mill to a building site where it becomes it's just used to pour the concrete. It's the frame that people use to pour concrete into a foundation or something, and then it gets thrown to the landfill and it sits there forever. And that's a very common, sad life cycle of a piece of wood. So that kind of thing is something we need to put an end to. But the nice thing about wood is that there's all these ways you can make it into smaller products. So you can kind of grind it up and make it into smaller products, and it has many uses. So wood is probably it's why we love it as a building material. It's why we keep going back to it. There's another side of this, though, that's a lot less lovely to think about. So wildfires, when they destroy our homes, one of the things we all need to be more aware of, and frankly this is an aspect of our policy work that really needs attention. There is a lot of vinyl in our homes today, in a typical American home. Vinyl siding, vinyl floors, vinyl appliances, etc. So this is polyvinyl chloride, is the actual material, and it's the same material, if folks remember the train derailment in East Palestine, Ohio last year, when that particular material spilled out into the community and caused great, huge impacts on people's health that will still be, we won't even really know them for decades. That's PVC. That material is used mostly in buildings. That's where it's most prevalent. We're the second largest consumer of plastics as an industry after packaging. And so when vinyl burns, it's extremely toxic to humans. People who are in wildfire affected communities where homes burned down, all of that vinyl is not just essentially becoming useless because it has been burned, and that material has really no ability to be reused in any way, but it's also poisoning us and everybody around the community that burns. So it's one of the reasons that we're very hopeful that that particular material, but really any material that has that ability to poison us, is regulated out of what we're able to build our buildings with. Because it's funny, I live here in California. I think it used to be maybe more of a conceptual thing for me to think, well, okay, if vinyl burns, but how often does that really happen? Well, these days in communities around our state and in many states in the US, unfortunately, our homes burn a lot more often than they used to. So we have to be assuming that that's going to happen and plan to build our buildings with things that will not poison us when they burn.
Thanks for that. So what is what it would be an alternative to vinyl siding? Are there like new products out there?
I mean, lots of things, stucco, wood siding. Oh geez. I mean, one of the nice things I have, and I think actually some of the audience here will particularly appreciate this. We didn't use plastics in our buildings until roughly the 1970s. So if you're kind of trying to imagine what might a building look like without plastics, just look around. Just look around for the buildings that were built in the 20s and the 30s and the 40s, 50s, and really any time before then. And I mean, there are metals you could put on the side of a building that would be better from a health perspective, maybe not always from an environmental perspective, but people can do that math. We can do those assessments now and compare these impacts. So yeah, a million things we could be siding our houses with that are not plastic. And yeah, sometimes it's a matter of just peeking back 50 years ago and thinking about how we built then.
Great, thank you. We have some questions about how these concepts and ideas are being taught and propagated. So are there current schools of architecture and urban planning that use this living building concept in their curriculums? And has the Department of Housing and Urban Development promoted or promulgating this concept?
Yeah, sure. Yeah. Okay. I'll start with the school piece. So many schools around the world do teach some form of building science, sustainability practices around how architects can be better stewards of our environment. It's typically starting from the basics, thermodynamics. So you got to understand, what windows to use and not to use. But can be up to the level, of teaching people about things like the Living Building Challenge, or otherwise preparing people for these kinds of opportunities when they get out of school. A lot of the work that we do is within the profession to educate people about how these work. And I guess I will say architects in particular do have some requirements that they have to be familiar with some of these basic concepts, not Living Building Challenge, but heat and light and system health impacts and those kinds of things. So there has been change in the profession to kind of demand that our expectations for accredited professionals in the architectural world know about these things, which is great. And it's one of the many fronts, right, that we work on to try to transform the industry. Yeah, I guess I'll leave it. Well, I mean, so I think maybe if folks want to know, there are schools that do this more. UC Berkeley, where I went, Carnegie Mellon is a great school for people interested in this kind of stuff. Yale has wonderful programs. Let's see, so maybe some cheaper ones I can mention. There's plenty of really great architecture schools that focus on this. And schools that focus on this, maybe even within something like the business school or the engineering schools or real estate, degrees and things like that. Yeah, they're all over the place. It's definitely growing. On the Housing and Urban Development Federal Agency, HUD. Yes, so one of the funny things, I won't go into the details, but yes, they do recognize and value and sort of provide extra financing for living buildings in particular. However, you tend to get the same amount of money for a living building as you would a basic LEED certified building or something like that. And those are much easier to pull off. And a living building sort of asks for more. So we have been working more and more with our friends at federal agencies recently to essentially ensure that if an agency, and this could be true of a city government or a state government, that the higher performing the building is, the more support it gets from its government, from an agency like that, to really incentivize higher performance over time, and not just any designation that says that you put some effort into sustainability, because typically it means that people go for the easiest designation they can get, if that makes sense.
Great, thank you. I think we have time for one more question. And this is just to kind of wrap up what we've talked about today, but how can people in this webinar make decisions in their own lives to help impact climate change? Yeah,
sure. So I think one thing is to ask the questions from people that you work with. Honestly, I live in a tall building, and I have a limited number of people I can work with in my own home to do little household projects. And so when I say things like, hey, can you make sure that the paint that you use is non-toxic? A lot of the first answers you'll get from people in the building industry is like, oh, it's all non-toxic, or I don't know what you're talking about, or don't worry about it, it'll be fine, just open the windows, or those kinds of things. So you kind of have to ask a couple of times and find good people, find people who care about this, find people who have a professional accreditation, find firms that you want to work with that look like they care. In every community, in every state in this country, there are practitioners of good, sustainable green building practices at all levels: architects, engineers, contractors, construction firms of different kinds. They're there, and they want to have clients who are passionate about this and who care. So I think the best way to start is just to look for the good people. There are a lot of in the chat there. I put this little BuildWell site, which is some friends that have started making videos that kind of help to demystify some of the work that we do. And there are other resources like that out there that try to just help make this, try to help you understand choices to make. So for another one that's great is the Healthy Building Network. They have a tool called Home Free. I think it may be called Informed now. They were going to change it. But the Healthy Building Network works a lot on making sure that people understand, even just within the category of flooring, what's the, is linoleum good or bad? And is it better or worse than cork or wood, or et cetera. So that's a good website, especially around health. but yeah, if it feels daunting, try to find some good people who want to work through it with you. They should be able to translate it into things that you can understand so that you can make the decisions yourself. You're not just delegating them to an architect or a builder. But you're gonna want at least for them to understand what you're saying in the first place. And that's that can be a challenge. So yeah, I hope
Great.
that helps.
Well, I think that's a good note to end on. Thank you so much, Lindsay, for being part of this program. And thanks to all of you for joining us this afternoon and for your thoughtful questions. If you enjoyed the program, please consider becoming a member or making a contribution to support educational programs like this. And remember to check out our upcoming streaming programs at smithsonianassociates.org. One more reminder before we say goodbye, we encourage you to fill out the survey when you sign off. We want to hear from you and we value your input. So thanks so much. Have a great afternoon.